Good evening, everybody. I'd like to start tonight by recognising Aboriginal and Torres Strait Islander peoples as the first custodians of the lands on which Australia was founded. Council acknowledges the peoples of the Kulin Nation as the traditional owners of the lands on which Windham City is being built. Welcome to the fifth and final event in our Energy Smart Homes program. We hope that you're now well and truly on your energy reduction journey. And if you've missed the previous sessions, they will be uploaded on our website in the near future, so do keep an eye out. But on to tonight's event, solar and battery information for your home. This one's going to be brought to you by Windham's sustainability team. I'm Daniel Mack. I'll be in the background helping things run smoothly, hopefully. Carolina will be managing our questions, and tonight's presenter is our very own Senior Project Officer, Warwick Tullio, who is responsible for delivering council's solar projects. This is a point of pride for us. Windham have the largest amount of rooftop solar of any Victorian council, so big shout out to Warwick and all his hard work in this space. Warwick has come down with a bit of a cold today, and he did have limited time in the office, so there may be a sniffle or two, but he couldn't miss the opportunity to preach solar to you guys tonight. So I'll pass over to Warwick now, and we'll get underway.
Thanks, Dan. I appreciate it. Just had to get my pitch off there. Welcome everyone to tonight's session, talking about solar for your home and batteries. I apologise for being ill. I have to say that up front. If there are some sniffles and coughs, you know why. But I wanted to give you everyone a bit of a rundown of, I guess, the key things that residents ask me when I speak to them about solar. But before I do, I wanted to let everyone know tonight that we are also hosting tailored advice sessions. We're calling them one-on-one sessions. That'll be with myself. So this is more of a in-depth technical discussion about solar, different quality tiers, brands, and it's a bit more specific to your home. I understand that everyone's sort of different stages of their solar journey. So, if you're at the very beginning, this session tonight may be enough for you to get started. But if you've done a bit of research and you've received some quotes already, and you need some advice at that point, then the one-on-one session may be better for you. So it's an independent, non-biased advice. I've worked in the solar industry for about 10 years before I started at Windham. And in the last four or 5 years, I've been looking after the commercial rollout for Windham. So I've seen lots of products come and go and lots of companies come and go in that time. So I'll be happy to help you out any way that I can, including doing a design specifically for your home, specification, and also following up, reviewing quotes, etc. So feel free to use that. There's a link at the bottom of the page there, but the team in the background will also be posting that, so you'll be able to get in and book some sessions. There are a limited number to begin with, but if you find that they all get sold out, please feel free to send an email directly to us at sustainability@windham.vic.gov.au, and you can register your interest and we can open up more sessions if required. Okay, so let's get into it. The key topics to cover this evening. Background, so I'm going to give you a bit of a snapshot on the solar facts and figures where we're at currently with solar installs in the country. We'll go through some of the common questions that I get asked from residents, and hopefully the slide package and presentation tonight will answer most of those for you. We'll give you a bit of a background on understanding your energy usage and a better feel for what size solar system you may need, and then we'll run through some design and install considerations. Just a general overview, as I said, not super technical tonight. We'll have a bit of a break for questions, and then we'll come back for the second half, which is probably what most people are interested in: components and warranties. How to choose a supplier, what manufacturer or products you should be looking at. Example system pricing to give you a feel for the market price at the moment, and then we'll go through the rebates and incentives and what's required from an eligibility point of view. And then to finish up, there'll be an overview with the next steps if you want to get going on your solar journey. So just to begin with, I thought I'd start by showing you this image, which shows irradiation or radiation across the globe. The yellow to red is very high areas of sunlight in particular, and you can see that Australia smack bang in the middle there is ideal for solar, one of the sunniest continents in the world. So look, most people understand that solar panels use the energy of the sun to generate electricity, so we won't really touch on that much. But I wanted to introduce the concept of converting light to electricity. It's actually called the photovoltaic effect. And PV is something that you probably see, and that's probably what differentiates solar PV systems and solar panels from the solar system with the planets that are out there. So that's what PV is. It just means conversion of light to electricity. One of the key things about converting sunlight to electricity is that it produces 0 greenhouse gas emissions when doing so. So it does it cleanly and it does it silently, which is really important. So just a little bit of data now on, this is a snapshot across the country on solar installs. More than 2.6 million small-scale rooftop solar systems have been installed in Australia. Small scale is classified as anything under 100 kilowatts in size, and that usually captures all of the residential systems that we'll be talking about this evening. So that equates to about 21% of residential homes. So 1 in every 5, which is pretty cool when you think about it, that 1 in every 5 homes now has a solar system on their roof. But of those 21% of homes, only 5% of those currently have a battery. So that might put things into perspective for you a little bit. It's not that many batteries have been installed to this point in time. So last year, there was over 378,000 rooftop solar installs, 2020, which was the most ever recorded. And the average system size passed 8 kilowatts for the first time. I remember doing a presentation similar to this a couple of years ago, and we were just over 6 kilowatts as an average size. So you can see that the system sizes are increasing, and that's mainly due to cost decreasing, I would think. So we added 3 gigawatt of new capacity last year, and that's the 4th year in a row that's broken a record. So you can see from the graph in the top right corner there how rapidly that's increasing. So Australia currently has the highest uptake of solar in the whole world, and that's 8 times the worldwide average. And I did a calculation, and it works out to be about 591 watts per person that's been installed in Australia thus far, which is pretty cool to think. And also last year, there were 23,000 small-scale batteries installed. So when they did the maths on it, it works out to be about 10 kilowatt hours per battery. So I just wanted to give you guys a little bit of a snapshot of Windham and how we're going in Windham, because Dan touched on it earlier. We've been doing really well from a council perspective installing, but not just that. We've been doing really well from a community perspective in terms of installations as well. So even though we were in the midst of coronavirus lockdown in Victoria last year, the top 3 postcodes in the whole of the country were still in Victoria. The second highest was 3029, which is Hoppers, Tarneit, Truganina. So I think that's a fantastic effort to be ranked 2nd in the whole country last year for installs. But not just that, 3029 ranks 3rd in total installs, and that's calculated from 2001 onwards. Whereas postcode 3030 ranks 14th highest from 2001 onwards, which is Werribee and Point Cook. So we're doing really well in Windham. We're leading the charge And I thought that was interesting to show you guys before we get started tonight. So some of the common questions I get asked by people is, why install solar? You know, how can I work out my energy use and reduce it? What size system do I need? What are the key components? What types of solar systems are there? You know, how do I know if it's a good quality solar system? How do I find a reputable installer? And obviously, what are the system costs and then the rebates? So those key questions, I suppose, have, I guess, designed the way that we're presenting to you this evening, and they're some of the questions that I aim to answer, including, what happens next if I do want to install a solar system. So why install solar? And I've split this into two main groups. There's obviously the financial side of things, reducing your energy bills, protecting against rising energy costs. You can earn a return on your investment with a solar system. Some solar systems will pay themselves back in 3 or 4 years. So that's a return on investment, 25 to 30% quite easily per annum. And some people don't think about it, but the more you invest in a solar system, it actually increases the value of your property as well. So that's the financial. And then we've got the environmental reasons, which is, we all understand that we need to transition away from fossil fuels and as quickly as possible to protect the environment. This is one way you can do so. Installing solar demonstrates a commitment to sustainability, obviously, using the sun to produce energy. You're building energy security for your home by offsetting your loads directly, and if you've got a battery in the mix, even including blackout ride through if you lose power, etc. And any excess energy that you're feeding back into the supply grid is localized, so the community gets the benefit of that, and it's clean energy as well. It's not brown coal generated energy. And really, I think solar, from my perspective anyway, solar is a bit of a no-brainer. If you can produce clean energy from the sun, why not? Just makes sense to do so. So before we get into the solar, when I used to work in the solar industry as a solar designer and solar salesperson, one of the things that we focused on to begin with was energy reduction. Energy reduction is key, I believe, because realistically, if you can switch off, obviously then you don't need to offset it with solar to begin with, but that's not always possible. So energy efficiency, I think, is probably the key next step. So upgrading appliances to have higher efficiency and lower energy requirements can be a really good way to reduce your overall energy consumption. And as a result of that, you don't need as large a solar system or battery to offset. So I just wanted to show you this slide because I thought it was very interesting about energy efficiency and where your energy actually is consumed in the home. I'm not going to harp on it too much, but heating and cooling potentially be 40% of your energy usage in a home, and hot water is 21%. So just looking at hot water and heating and cooling, you can potentially reduce your energy consumption a significant amount. Right. So for heating, on the heating side, each degree over 20 degrees Celsius uses 10% more energy. So just reducing, the thermostat on your heater by a couple of degrees can make a big difference. And the same is true for cooling, where each degree under 24 degrees is 5% more energy consumed. But I thought, tonight we're talking about solar panels, we're talking about solar systems and batteries. And hot water is one area, I think, that people often overlook. I consider electric hot water units to be a thermal battery. So if you can't afford to install a battery now, focusing on electric hot water storage or upgrading to electric hot water storage can be a really good way to use solar energy, particularly if you can afford a heat pump. Heat pumps are really efficient. They have a coefficient of performance, some of the good ones, between 5 and 6. That means that if you put in 1 kilowatt of electrical energy, you get out 5 or 6 kilowatts of heat energy. So there's amazing savings there, particularly if you consider hot water as a thermal battery. So what size solar system? Put my solar designer's hat on just for a second. I guess these are the key considerations from a solar designer's point of view. So understanding how much energy you use and you're looking to offset, that's obviously key. Then how much roof area you've got to install solar and your available budget. They're the three main areas from a solar design point of view that we need to consider when designing an appropriate solar system for your home. So energy and offset expectations is something that we'll talk about, because it depends. If you've got a battery in the mix, then it makes it fairly easy to offset energy, because you can capture excess solar in a battery and then use it after hours. So the big question is whether you're going to have battery included up front or whether it's something that you want to add down the track. So understanding energy use, let's get into that. The easiest way, obviously, is just to have a look at your power bill. The power bill will give you your average daily energy usage. So in this example here, 25 kilowatt hours, 22 last year, but it also gives you a fair breakdown of how much energy you use different times of the year, so winter and summer. So just looking at this bill here, it looks as though heating over winter is when they don't have as high electricity bills, so they're probably heating the home with gas, I'd say. And then over summer, the costs increase or the energy usage increases, and that's most likely attributed to air conditioning loads. There are other ways, though, that you can check how much energy you use, and it can be really important when you're considering solar to understand at what times of the day you actually use your energy. So getting a good 15-minute snapshot of what's happening over the course of the day can be very valuable before you look at installing solar, because then you know whether it's morning, midday, afternoon that you use your energy. So we can do this either via smart meter interval data, and you can access this usually through your retailer or through your distributor energy portal. You can access your meter data directly. And other ways to do this is by installing third-party energy monitoring devices at your switchboard. So roof considerations. Obviously, if you don't have a large roof, then you're not going to be able to install a large solar system. But the key things to consider here are, how free the roof area is. You might already have gear installed up there. You might have solar hot water as well. You might have pool heating, for example. So understanding how much free roof area is really important first step. Then the roof angle and the direction of the roofs can also play a part. In an ideal world, if you wanted to generate the most energy from solar, you'd be facing the panels north. For our latitude, it's probably somewhere around they say equal to the latitude is 37 plus or minus 10 degrees. So as far as the angle is concerned, so most house roofs I think are about 22.5 degrees. So it's a little bit outside the optimum, but it works pretty well for good annual generation. So I wouldn't be too worried about that. If you've got a flat roof, for example, and in the image there you can see that they've got a garage roof there that they could put some panels on. You can pretty much face the panels any direction. You get to choose the optimum angle for you. Other things to consider on the roof are going to be shade influences. So if you've got lots of trees like I do at our house, for example, you need to consider what parts of the roof may be shaded at different times of the day or different times of the year, as it may be. And other elements, you know, TV antennas, for example, air conditioning units, they can all cast shadows as well. So solar panels don't typically like to be in the shade, they like the sun. So these are all roof considerations. So offsetting energy. Now, I understand this evening they're sort of talking about, you know, standard solar systems. We're talking about solar systems with batteries, or we're talking about, you know, something that might be a standard solar system that has a battery added later. So, you know, in order to try and, I guess, cover most bases, we'll talk about, you know, just a standard solar system to begin with here. So looking at the image, the solar production curve is the green one, assuming that the panels are facing due north. You know, obviously the sun comes up in the morning, by midday, you know, early afternoon, then you're producing your peak out of your solar system, and it's tapering off as the sun starts setting. But in a residential home, interestingly enough, the energy usage or consumption profile is typically fairly common from household to household. I mean, it'll change a little bit, particularly now since we've been working from home so much, etc. But, you know, if we're looking at a standard consumption profile, that's the red one here. So you've always got a base load of energy. Your home always consumes energy for powering your fridges. You know, you got standby loads going on. There's always, you know, some lights most likely going on. So it's always going to require some form of energy. This little peak here is the morning peak, where you get up and you make your breakfast, you know, you start turning lights on, you might have a shower, whatever it is, and then typically that flattens out and goes back to a normal sort of consumption profile over the day. But then in the evening, or the late afternoon evening, when people come home from work, and this may not be as typical, particularly after the last year of working from home, but you know, this is usually when you start turning TVs on, heaters on, whatever it may be in the afternoon. So you've got two peaks, one small one in the morning and one larger one in the afternoon. So you can see how that solar generation curve doesn't match nicely when we're actually using the majority of the energy in the home. Okay, so solar systems obviously only generate energy when the sun's shining. Okay, you know, they can be designed to generate enough energy for your needs over the course of 24 hours over every day. The problem being, obviously, that if you don't have a battery in the mix to begin with, then what we need to do is we need to think about ways where we can start shifting either this solar production peak to morning and afternoon, or we need to start shifting our energy usage to be more in that middle of the day period. So energy offset expectations can change depending on the type of home you've got, the orientation of your roof that we touched on, and there are some smart design things that we can do to change when your solar system generates power by changing direction, for example, of the panels. So here in that previous example of the house, you can see that, you know, they've got panels facing north, which is up, they've got panels facing east, and they've got panels facing west. So this is one way that you can actually change when your solar system generates its energy. And, you know, if you're not considering a battery now, and you don't think you'll be getting one anytime soon, then these are really smart things that you can do from a design perspective to try and, you know, match that consumption profile more closely. You know, solar panel direction has a big impact on how much energy the system will generate. You know, the angle of the panel also will, and the time of year. You know, typically in summer, you'll generate twice as much energy as you will in winter out of a solar system. And that's usually just because the days are longer and you've got more peak sun hours, and we'll touch on that soon. But it also has to do with temperature. Solar panels don't like to be hot. Their conversion efficiency actually drops the hotter they get. So interestingly enough, on a shoulder period day that's not in summer, for example, when you've got a nice, say 20, 21 degree day with a slight cool breeze blowing, you'll actually see that your solar panels are generating more power in any one snapshot in time than they would over summer. Only because the days are longer in summer is why you generate more energy over the course of the day. You've got more sunlight hours hitting those panels. But most people don't understand that, so I thought it was an important point to note. So yeah, matching energy use. I think if you can load shift in the home, you can do that, either by changing your habits. That's pretty easy to do, or smart appliances or via timers is another good way to do it. For example, I touched on the heat pump before. If you were to install a heat pump, you can actually have a timer to turn that on during that midday peak solar production period. So actually all of your hot water is actually coming from your solar panels. And you can do that with some other appliances in the home as well. Some of the smarter ones these days will have delay timers. So, if it's a washing machine or dishwasher, for example, you can delay the start on those to be later in the day or to match when your solar is generating the majority of its energy. So this is a very, very basic system sizing example for you guys. And, there are lots of things that come into play from a solar design point of view when you ask for a quote. And I've got a note or a disclaimer down the bottom, but I think a performance and production output report for your system is really important. So always ask the solar company to provide one of those for you, because what that does is it takes into account all the losses in the system that they're proposing for you. So, there's losses through the inverter, there's losses through the wiring, depending on the panel orientation and angle, or the time of year, there are different losses associated with solar systems. They're not 100% efficient. And the longer that the solar system's been on your roof, the dirtier it gets, the more impact there is in terms of overall production. So this is just a very quick back of the envelope calculation, but you need to know how many daylight or daily energy, you need to know what your average daily energy usage is to start with, and that's obviously, we can get that pretty easily from our power bill. You need to know the average peak sun hours for the location, so for Melbourne, and obviously then you can work out the solar system size from that. So if we use the example of 20 kilowatt hours a day, which is quite high energy usage, but I think it will serve the purpose. The peak sun hours for Melbourne are about 4.5, okay? But if you use the figure of 4, that takes into account some of these potential losses that we've been talking about as well, okay? So divide 20 by 4 and you get how big your solar system will need to be. That changes. Okay, so the 5 kilowatt system won't generate 20 kilowatt hours a day every day. It'll, on average, over the course of the year, that's what it would generate. Probably generates half of that in winter and maybe even twice that in summer. So just be aware of that. So I think what we'll do is we'll pause there to see if there's any questions that have come in that first lot of slides before we move to the rest of the presentation.
Hey Warwick, I think we're looking good. You seem to be answering everyone's questions because we haven't got any popping up yet.
Perfect. That's what I like to hear. I think the questions are going to come in the second half, to be honest, but that's okay. All right, great. Let's. I might just have a sip of water and then we'll move on. Okay. Feel free to pop your questions in. And Carolina, if any questions come up as I'm talking to the slides, feel free to interrupt. Okay, so I just wanted to give a general overview of different system options. And as I say, this session today isn't going to delve into the nitty-gritty and the technical detail. So we'll certainly do that on one-on-one sessions if you like. But I guess the top dot point there and the associated image off to the right is what I call the sort of the most common solar system. You got solar panels on the roof, you got your solar inverter, which is the brains of the system. It converts DC to AC to supply energy into your home or export out to the grid. So that's the most basic type of solar system you can get. Sometimes you'll hear these systems referred to as battery ready. Sometimes you won't, but really what it means is that there's no battery in the mix at this stage. So the second classification there is for a grid connected solar, so that the first example, but with an AC battery attached. Now, AC batteries are becoming more and more popular, sometimes referred to as AC coupled systems. It's pretty much exactly the same thing as the first one, but you can install a battery at any stage quite easily because the battery doesn't get wired to your original solar system. The battery actually gets wired to the switchboard of the home, and then you have consumption monitoring, so you can tell how much energy is coming from the solar, so it can decide when it should be charging or not charging. So it's a really simple form of adding a battery to a grid connected solar system at some stage down the track. These are just grid connected options, okay? Because the purpose of today is to talk to you about residential solar. There are off-grid options, and there are a myriad of other different setups you can have with solar systems, but I think these are probably the three most common. So, and the final one there is, rather than an AC battery, you've got a DC battery in the mix. In order to do that, however, the inverter has to change. So the inverter needs to be a hybrid inverter. A hybrid inverter, what that allows is for direct charging of a battery before it gets converted to AC. So DC from the panels through the inverter, charges the battery in DC. Most efficient. There's not losses like there are on the AC battery because it's not converting from DC to AC back to DC again, etc. So a lot of people like this approach. A lot of people like having a hybrid inverter in the mix so they can add a DC battery later on. What it does mean, however, is you would need to install a hybrid inverter up front, typically, to make it easier to add that DC battery later. So it's not quite as easy from a installation point of view, because you've got to consider upfront what you might want and what you might need. There are advantages and disadvantages to both, but needless to say, if you are considering a battery at a later date, there are options. You can always go for an AC coupled battery option. So I just wanted to point out, however, that not all batteries have blackout capability or blackout ride-through capability. So most people think automatically that if you've got a battery and the grid fails or goes down, then you can run your home from the battery. It's not always the case, okay? So I just want to point that out. If that's really important to you guys, then make sure you ask for backup or blackout ride-through capability when you're looking at batteries.
Warwick, can I just interrupt you for a second, because we do have someone ask a question, blackout ride-through. You mentioned, what is this? Could you explain?
Yeah, so I mean, it's basically using the energy stored in the battery to run your home if the grid fails. Okay, so if there's a blackout on the grid, you can then run your home still from the battery. So one of the issues with grid connected solar is that one of the requirements for the solar inverter is it needs to sense the grid to operate. Okay, so if the grid is down for whatever reason, so it's a blackout type situation, your solar system won't work. It has to do that from a safety point of view, because if there are people out in the street working on the lines trying to fix whatever the issue is, like a power pole's come down or something, you can't be exporting energy into the supply grid at that time. So it's a requirement for all grid connected solar systems to disconnect from the grid whenever they sense that it's not there. Okay, so blackout or backup capability allows you then to draw energy from the battery in that situation and run your home, typically what you'd do is you'd run only essential loads because you don't know how long the blackout's going to be for. You know, you want to keep your fridge running. There might be other, you know, critical appliances that you need to keep running in those type of situations. So typically in a blackout ride through situation, when you have a battery installed, they will reconfigure your switchboard to make sure that only the essential loads are backed up via the battery during times of need. So hopefully that's answered that question. So let's move on to the key system components. And you know, we've spoken about the different system types, including batteries, but I suppose I wanted to touch on the fact that there are different, there are standard solar systems. Most of the systems are standard solar systems, but there are also more advanced solar systems that you can get. Not everyone needs an advanced system, but I thought it would be worth pointing out. So, you know, the solar inverters is the brains of the system. It does all of the conversion from your solar panels from DC to AC. It then sends that energy into your home or out to the grid, as we touched on earlier. So the solar inverter is the point of the system that can potentially fail. Okay, it's, and I use this, someone told me once, it's kind of like having 4 laptops strapped to your wall that works, you know, all day, every day for, you know, potentially 10 years. Eventually something is going to break. Something is going to go wrong. So it's really an area that you should spend time on, and I would recommend, when you're considering getting a solar system, make sure that you get a good quality solar inverter, because it is the weakest link. So that's kind of the standard system, and I'd say, you know, probably 90% of solar systems installed out there are pretty standard panels, inverter. You know, that inverter gets connected to your switchboard and away you go. There are more advanced options, and they're DC optimized systems or microinverter systems. I'll talk about DC optimized and microinverters as the same thing, even though they're not. But really what it does is you have an optimizer or microinverter on the back of each solar panel up at roof level. So a DC optimizer takes a string inverter to the next level. It gives you more advanced functionality. You can see what's going on with individual panels in your solar system, for example. It also allows you to change the direction of the panels on the roof and the orientation of the panels more easily from a design point of view. These are the types of systems that you'd be looking at if you have heavy shading on your roof, for example. You know, probably to take one step further back, it's solar panels don't like shading. So string inverters, or the standard string inverters we're talking about, a number of panels attached to each other at roof level. If one of those panels is, and they're all wired in series, so if one of those panels is in shade, the rest of the panels don't function either. So by introducing DC optimizers or microinverters into the mix, you're effectively breaking that string or that chain. So each panel can then function on its own and isn't reliant on all the rest of them that are wired to it. So that's why I've got them there as more advanced options. They do cost more, but they have plenty of additional capability that comes with them as well. So thought it worth noting at this point in time. You don't have a string inverter with microinverters, obviously. They have just a small microinverter behind each panel at roof level. Microinverters do all the conversion of DC to AC at the panel on your roof. So the cabling that runs down to your switchboard is AC cabling rather than high voltage DC cabling. So some would consider that to be safer also. Okay, so solar panels. Different types of solar panels. Those monocrystalline, polycrystalline, and thin film are probably the main types of solar panels that are around at the moment. You know, thin film used to be big years ago when I started the industry, but they're quite inefficient and quite large. Thin film panels, or amorphous silicon, they're the ones that you get in the solar calculators, for example. That's probably the best way to explain what a thin film solar panel looks like. Monocrystalline and polycrystalline, you can see the examples to the side here. Traditionally, monocrystalline has been more efficient than polycrystalline, but has a higher price tag as a result of that. And also traditionally, they have a better temperature tolerance. So they tend to perform better under hotter conditions. But, advances in polycrystalline and monocrystalline panels seem to change year on year. Tends to be a bit of a race where, the efficiency of one increases and then the next one will increase in line with that. So polycrystalline panels are typically not as efficient as monos, and that's why you'll see most of the panels being installed these days as monocrystalline. One way you can tell visually is polys are usually a really dark blue color and monos are usually a black color. It's not always the case, but it's a pretty good general rule of thumb. I've also put half-cut solar panels on the side there because a lot of the panels being installed these days are of the half-cut variety. Just means the cells are cut in half, so you've got twice as many cells. There are some advantages in terms of efficiency over half-cut monocrystalline panels, increases in output, for example, but they're also a bit better from a shade tolerance point of view, just with the way the cells are actually wired inside the panel itself. Okay, we'll move on. So array framing, obviously.
Oh, sorry, Warwick. We do have a question just regarding panels as well.
Sure.
So I've just lost it for a second. Is it more expensive to install panels over multiple sections of roof, e.g. Some in the north orientation, some west, some east?
Yes, it is. The reason, it's not that much more expensive, okay? But because the installers have to start effectively on a different roof section, it takes a bit longer for them to set up again on that section, to install the framing, etc. So, typically you'll see a slight increase associated with the number of roof areas. It's not huge. I mean, I think depending on the company, it might only be a couple of $100s, but some companies will charge extra for that because there's additional labor and time involved. Some won't. So there typically is an increased cost associated with it. But, having said that, the benefit can outweigh that additional cost, because obviously if you're spreading solar generation over, morning, afternoon and evening on your home, then that can match your consumption profile a lot better. So are there any more questions there, Dan?
So we did have one relating to inverters as well. Joanne just asked, how would I know what a hybrid inverter is? I guess when you're shopping around.
Yeah. So look, pretty much, well, most, if not all, manufacturers will probably have a hybrid inverter in their range. There are some hybrid inverters that are just marketed as hybrid inverters as well. So, for example, there's an example here, the Fronia string inverter we're looking at there in that image. They have a hybrid in their range as well, or different output hybrids in their range. So it's just a matter of asking for that from your solar provider. But if you're getting batteries up front in a hybrid type arrangement, then obviously they're going to choose a hybrid inverter for you if you're going for that DC or DC coupled version. But if you want to have a hybrid inverter installed now and then batteries at a later date, you just have to make sure you ask for it. So yeah, that's key. So definitely have that conversation with your solar retailer. Okay.
We do have a couple of questions on feed-in tariffs, but I believe you're going to be coming up to that soon.
Yeah, one of the end slides covers feed-in tariff and what the changes are. So hold on tight. So look, I'll see if I can get through these components, because the next, I think a lot of people overlook system monitoring, but I think it's really important for a solar system. It's probably one of the most important things, particularly if you're installing batteries especially if you're installing batteries later, because you want to know what your system is doing at any one point in time. You want to know when you're generating power, you want to know when you're consuming that power on site, and you want to know how much excess power you've got that you could capture in a battery. So system monitoring, to me, is super critical for a solar system. And really, the cost of a system monitoring package, particularly if you get something that's branded with your inverter, isn't that much. There are third-party system monitoring, and I think the next slide sort of touches on different options. So we'll give you some screenshots there. And then battery storage, obviously, is the final that we've been talking about for these key system components. So just onto that monitoring system examples here. As I said, it's highly recommended from my point of view. Particularly, early on, I thought monitoring systems were really important, because if you want to keep the manufacturers of the components you purchased, honest, you want to know if the system is actually performing as it should. You get warranties with your panels and with your inverters, but if you've got no way to double check and map how much energy is being produced over time, then it's a very difficult conversational argument to have. If you've got it in front of you, then it's a lot easier to say, look, my production has dropped off by X amount, whatever it may be. Here's a couple of different examples on screen here. So we've got, the solar production being yellow on this one, purple being the house energy consumption, and they've even metered their hot water. So you can see the peak production up around 2 kilowatts there for a period of time for hot water. So you can actually, with third-party consumption monitoring systems, pretty much monitor any circuit in your home. If you wanted to know what your heating and cooling was doing, for example, you can do that. So it's a really nice way to be able to tell what your system's doing, how much energy you're producing, and when you're producing it. So getting back to maybe this changing of when you're consuming your energy in the house, it gives you this snapshot of when you can start shuffling things around a little bit in terms of turning things on or off. This example over here is, and just the point being, with monitoring systems, you can get them for your desktop, your laptop, your tablet, or your mobile phone. Nearly all monitoring systems have a mobile phone interface now. This is a snapshot of a microinverter system. This final image over here on the right is just a close-up of 4 of the solar panels, for example. You can see how much energy each of those solar panels has produced. You can also see pretty much instantaneous output in terms of wattage from solar panels. You can do the same with DC optimized systems as well. When you've got a battery in the mix, which is the first image here, you see how much is actually being charged from your solar, how much is being discharged from the battery, where the energy is coming from your solar, how much you've imported from the grid. So it gives you really all of the information at your fingertips. How much you've imported, how much you've exported, how much you've stored in your battery, for example. And this is just a snapshot over the course of the day of imports, exports, etc. So, pretty cool information if you're into that. If you get a DC optimized or a microinverter system, all this monitoring capability comes free with that package. If you get a standard string inverter system, it doesn't always. So you want to look to ask for that as an optional extra, or you can get a third-party monitoring system like the example on the left here and attach that to any solar system or circuits in your home. Okay, component warranties. So these component warranties can be a good indicator of quality, not always, but they can be. So I just want to touch on inverters, panels, and batteries. So solar inverters, like a standard solar inverter warranty, is typically 5 to 10 years for a residential inverter. So this is an area where I think you should pay a lot of attention, because there's a massive difference between 5 years and 10 years, or even more. You know, and some inverter manufacturers will offer extended warranties, you know, over the 20-year mark, but you pay for that. So look, from my experience, if an inverter is going to fail, typically does so in just after the 5-year mark, but not always the case. So if you've got a 10-year warranty to back up your inverter, or a longer one, you can feel pretty safe with your investment. And if anything goes wrong, you'll have a warranty to cover it. Typically what they'll do is they'll replace it, no questions asked. It may not be a brand new product, but they'll certainly replace your inverter like for like, because depending on what happens over the years, models can change, etc. So, so yeah, just keep an eye on that. I think that's really, it's an area that you should focus on, particularly as I think the solar inverter is, you know, the key component in the solar system. So solar panels also come with warranties. They come with 2 warranties, actually. There's a manufacturer warranty and there's a performance warranty with solar panels. The manufacturer warranty typically starts at 10 years. A lot of solar panels are sort of between that in the 12-year mark from a manufacturer's warranty. So if any defects occur in the first, you know, say 12 years, that'll be covered under that manufacturer's warranty. A lot of the higher end solar panels will offer 15+ years. You know, some of the really top end solar panels will offer a 25-year manufacturer warranty to match the performance warranty. So, I mean, I think solar panel warranties is usually a pretty good indicator of their quality. But having said that, you know, there's not a lot that can go wrong with a solar panel. It's got no moving parts. It's got no, you know, electronics that can go bung. Really, once it's on your roof, there's not a lot that can happen with a solar panel. But there are differences in quality, obviously, and you know, some panels will degrade faster than others. So it's important to get a warranty to back up the price you're paying for that panel. And a performance warranty, most solar panels, or nearly all solar panels, have a 25-year linear performance warranty. And what that typically is after the first 10 years of operation, they have to be functioning at 90% of their rated output, and after 25 years, 80% of their rated output. So even after 25 years, solar panels should be putting out 80% of its nameplate rating. So if it's a 300 watt panel, it should be at 80% output of 300 watts. And batteries. So, you know, there are so many different batteries in the market, and we're not going to get into the technical details between different types of battery technologies today, but I guess the most common in the market at the moment is the lithium or lithium iron phosphate batteries. So I've just put battery warranties based on that, but they change from manufacturer to manufacturer. So it's really important that you read the fine print with a battery warranty, okay? It changes from brand and technology that you get as well. But it's typically around 10 years for a lithium ion battery. And the warranties are usually based on the number of full charge discharge cycles. So one full charge and discharge is 1 cycle. Okay? So some battery manufacturers specify that you're only allowed 1 cycle per day with the battery, and that's how they calculate you know, how long. So you have to look at how many cycles, and if it's 1 cycle a day, you know, it'll be about 3,600 cycles to get to your 10-year mark. But other manufacturers will allow more than that. So I think one of the batteries is 2.7 cycles per day from a different manufacturer. So, you know, it's an area where you should really read the fine print and speak to your solar provider about that, because battery warranties can change depending on the brand and the technology. Look, I'm not going to get into a detailed discussion about brands either, but and you know, cost can be a good indicator of quality, but not always. You know, there are some poor quality components out there in the industry that are, you know, marketed as being top quality and asked a premium price, and you know, they're really not. So I'm showing you these charts today. I've taken them from a website. You can see the link there, solarquotes.com. It's it's an independent resource. It was started by an ex-CSIRO engineer. I think the information they have is really good. So if you want more information and detailed information on pretty much anything, batteries, inverters, panels, it's a good resource. I tend to agree with quite a lot of the information. And I just wanted to show you these two examples about solar panels and solar inverters. These are the main brands, main recommended brands by this website. And you got entry level on one side and you got your top end on this side. And I think something like this could be a really good resource for people that are receiving quotes to see, what brand of solar panels you're being quoted and what brand of inverter you're being quoted and where that falls on this, cost quality graph, I suppose it is. But yeah, we're not going to delve into the brands today, but your top end panels and your top end inverters are typically the ones that have the longer warranties. So that's also a good indication of quality in most cases. So are there any? Keep moving on.
Warwick, I just have one question. Does it make a difference AC or DC batteries? I know you just spoke about batteries not long ago.
Look, I don't think it, honestly, I don't think it makes a difference. I think DC batteries, there's an efficiency there because you're pretty much charging from your solar panels via a charge controller as opposed to the batteries in DC directly. So there's an efficiency gain there. Whereas with an AC battery, you're converting because the AC batteries are all-in-one units. So you're converting what's being generated on your roof to AC, and then you're converting it back to DC to store in the battery. So there can be some cost savings, I believe, depending on the brands associated with DC and hybrid type setups. But realistically, I think these days, because there are so many all-in-one AC batteries available in the market, and the most common of which from our friend Elon Musk, they're pretty rock solid. They can be installed very easily, added to a system at any stage, and I think realistically it just comes down to personal preference. I mean, I wouldn't say one is better than the other at the end of the day because it really depends on your situation. Are there any other questions that have come through?
I might leave some of them for a little bit later towards the end, just in case you answer them.
Okay, cool. So just touching on the key manufacturer considerations now. So, always aim for quality, and I understand that it's difficult to know what's good quality and what's not good quality. So once again, feel free to book in for a one-on-one session, and we can discuss different products from my personal experience, if you like. But you pay for what you get, and it's true in the solar industry as it pretty much is in everything in life. So try and pay more, particularly for those key components that we've touched on, and make sure you get the warranties to back up the products. There's so many different manufacturers and brands out there, and I understand how it's really difficult for people to sort of, when they're starting out, to know what to look for. So particularly if you're going for the rebate, you have to install a Clean Energy Council approved component. So there's a list. We have a link at the end of the presentation today. So that covers panels, inverters, and batteries, battery energy storage systems. So feel free to look at that at your leisure. But I think also in this day and age, being online, you know, there are independent reviews and customer testimonials from some of these sites, and I mentioned solarquotes.com before. It's a good resource, and they do have these customer testimonials, and some of them are, you know, honest and brutal. So, you know, that can be a good way to get a feel for whether a component is performing, and even if an installer is performing. So just keep that in mind. The country of origin of manufacturer is also, I just want to highlight this because it can be misleading. Sometimes, you know, you hear that, oh, you know, this brand is from country A, but then you find out that actually they're manufacturing all of their gear in country B. So, you know, you think you're paying for something that you're actually not. So just make sure you do your due diligence. All components come with a data sheet, so you'll be able to see where they're manufactured, and that has to be shown on the data sheet. So that's a good way when you're asking for a quote. Make sure you get your data sheet so you can tell where the products are actually being made. Look, company brand name, reputation, and time in the industry is, I think it's really important. I've seen companies and manufacturers come and go over the last, you know, 14, 15 years in the solar industry. And, you know, really the ones that have been in the industry a long time, they're the ones that back their products. They're the ones that don't cut corners. They're the ones that, you know, really have high quality offerings for their customers. And, you know, sometimes you'll have, you know, what is a good quality component all of a sudden have a recall. Happened to a battery manufacturer not so long ago. It happened to probably the, you know, the best string inverter brand in the market at the moment. But what they did was they didn't run and hide. They, off their own bat, they went and took all those faulty products, they replaced them free of charge, they kept their customers happy, and they built their brand bigger and stronger. So, you know, these things can happen from time to time, but it's all about, you know, that reputation and the time in industry, because, you know, once you've built a reputation, then it's more likely than not that they're going to remain for a longer period of time anyway. And then obviously warranty, we touched on warranty, so I'm not going to go back over that. But having a local office, I think, is a really important point. A lot of solar component manufacturers don't have a local office in Australia. They don't have any representation whatsoever. So pretty much you're relying on your solar install company to chase anything up from overseas if anything were to go wrong. If that installer goes bust or leaves the industry, then you're stuck with a product that doesn't work, and it's up to you potentially to ship that overseas at your cost to get it repaired. So I think this is a really important point, is make sure there's a local office in Australia, particularly for your panels and inverters. They're the key items that you'll need support with if anything were to go wrong. So doing a quick review to see whether, you know, if there's an Australian head office here, you know, can save heartache down the track. And some manufacturers will also offer a third-party insurance protection. So if they were, you know, to leave the market for one reason or another, then the products are backed by this extra layer of insurance over the top of, which means that, you know, you'll either get your money back or you'll be able to change it for a like-to-like product. So that's also something to consider. Okay, in line with manufacturers, how do we choose a solar supplier? There are so many out there. I don't know how many thousands there are at the moment, but I know when I worked in the industry, there was, you know, there was more and more coming online every single year. So, you know, how to find a good one. You know, I think the key here is the Clean Energy Council's been doing a really good job of policing what's happening out there in the field with installers. Make sure that your solar supplier is a Clean Energy Council or CSC approved retailer. That's the first step. You know, approved retailers have a code of conduct that they have to commit to, right? So that's high levels of quality and service, and that's built into this code of conduct. So I think it's really important that they're a Clean Energy Council approved retailer, so ask for that. You know, also check to see whether they've got accredited designers and installers on staff. That can make make it really important, especially from the start of the process when you've got a designer involved, designing a system for you. And then obviously later on when you're getting your system installed, make sure that they've got accredited designers and installers. You know, to get your accreditation, you have to obtain 100 points every single year to keep that accreditation, which means that you're constantly upskilling, you're in touch with any changes in the industry, you know if there are any safety issues to be wary of. So that accreditation is super important. And if you want to apply for a rebate, you have to make sure that you're using them. So from a solar supplier point of view as well is, you know, ask the question, do they use subcontractors to do the installs? Do they use in-house installers? You know, I always used to think that in-house installers were the key, because then you could quality control all of the jobs and all the people that are out there in the field. You knew what was happening. But, you know, these days, a lot of companies use subcontractors, and that's fine too. But the better ones, I believe, will use the same subcontractors over and over. So they do have that oversight in terms of what's actually happening in the field. You know, if there are companies that are sort of swapping and changing their subbies and installers all the time, then I think corners can get cut. So that's an area that you definitely want to ask about. So also the installer warranty period can change. So, you know, some companies will offer 1 year warranty, some 2, some 5, some even 10. You know, so, you know, it may not mean much if the company doesn't exist, but, you know, I think companies that are willing to offer longer term warranties, you know, take pride in what they do good jobs. They know that they don't want to go anywhere in the future. They don't want to back out of the industry. They want to do the right thing by their customers. So, you know, I think that's really important too. So installer warranty is an area that you can focus on. So look, and this is a difficult one, but, you know, some companies have been in the industry a long time. Some companies do have a proven track record, and some companies, you know, are reputable as a result of that. You know that they've done the right thing to remain in the industry through the solar coaster, as we used to call it. You know, but there are a lot of new companies coming online these days, and it doesn't mean that the new ones are as, you know, any worse off or any worse than those sort of original companies that have been around a long time. So, you know, I think that's when the next point is really important. Always speak to a referee. You know, always ask to speak to a referee, and always check customer reviews and testimonials where you can, because, you know, the people that are posting those typically, you know, aren't forced to do so. And that's, I guess, the difference between being asked to be, you know, call a referee. They obviously are going to say nice things about them, whereas online reviews and testimonials can sometimes be a better indication. And finally, always ask to get 3 quotes and compare companies. Don't trust the first one that you go to. Always check, you know, different companies' pricing, and you can get a good feel from what a company is like based on the first what service you're receiving from the very beginning. You know, if they're taking the time to explain things to you, step you through it, it's a fair indication that they'll also be taking the time to do a good job on your installation, follow up from a, you know, don't go for someone. I don't think that's going to end well. Okay. Sample system prices. Were there any questions before we move on?
Sorry, Carolina, you go.
You go, Dan. Go, Dan.
I was just going to say, no new questions just yet. We might push on and keep them to the end for the minute.
Okay, perfect. Thanks. So, example system prices, and this is you know, I've got an asterisk here saying that they should be used as a guide only, and they should be because they change depending on a number of different factors. But the pricing below includes an STC, this small scale technology certificate discount, but excludes the current Victorian government rebate. Okay, so this is before rebate. The graph here is from Solar Choice. They sort of compiled data over time. The blue line is the one that is of most interest to us, being in Melbourne, and you can see how prices have dropped from, you know, $2.50 per watt down to somewhere around the $1 per watt mark now, and that's only in a matter of sort of 8 years. So, you know, things are coming down in price. Solar panels are definitely coming down in price. I don't necessarily think inverters have come down in price too much, but solar panels certainly have. So I thought it was interesting. So these prices are based on a 5 kilowatt system. Okay, this is an average cost for a 5 kilowatt system with no battery. This is just the solar system. Okay, and this covers those three system types we just spoke to earlier in the slides. So a standard string inverter, you know, you're looking at $5,000 to $6,000 for a 5 kilowatt system. That's about $1 to $1.20 per watt. A lot of things are referred to in the solar industry by the dollar per watt cost. Okay, so that's why I just put that $1 per watt cost there for you. So the smart, or the more advanced system, which is the smart string, the DC optimized one we spoke about, it's the next sort of level up, and you're probably expecting $6,000 to $7,000 for a 5 kilowatt system before any rebates. And then the micro inverter system is usually the next tier up in terms of pricing, and that's the $7,000 to $8,000 mark. Okay, but these are average, as I say. It'll change from supplier to supplier, depending on where they buy their components from. They might get better wholesale prices because they deal with certain brands more so than others. So the prices can vary quite a bit. Some example battery prices for you. Once again, from Solar Choice, you know, this is current as of May 2021. Battery pricing, you know, there's two columns here in the table, and it shows you different battery capacities. So 3, 8, 13, and 18 hours in terms of the energy storage capacity, and what the price is. So the battery only price is if you're going to upgrade a hybrid inverter, let's say, and just add a DC battery, you're probably looking at those sort of costs. If you're installing an all-in-one, the AC battery we spoke about as well, or a DC battery with a hybrid inverter, then you might be looking at something, the battery inverter charger type costing there. So I just wanted to put this graph in because I thought it was interesting. You know, the index or the flat line here, and that's what it is. It shows that battery prices have remained relatively stable in the market since, you know, June 2018 until now. So I think everyone expected battery prices to come down, and I think people still expect battery prices to come down. But I think the logic there is, you know, once more and more batteries start being sold, then you'll see that price start coming down as well. Also, with electric vehicles coming online, you know, that'll impact the lithium-ion battery prices as well. But so there's a big range there, as you can see, and most battery prices, when we talk about battery prices, we talk about dollars per kilowatt hour. Okay, like dollars per watt with the solar, the solar panels, etc. With batteries, it's dollars per kilowatt hour. So you can see that, you know, smaller batteries cost more per kilowatt hour currently, and as you start getting down to the larger batteries, that purple line there, you know, you're approaching that $1,000 mark per kilowatt hour. And I've just got an example. This is a very basic cost example of a 13 kilowatt hour battery, which is probably the most common size that's being installed for one reason or another, such as Powerwall That's kind of capacity of that one. So you're looking at, $14,170, which is about $1,090 per kilowatt hour. What that equates to is 30 cents per kilowatt hour over its warranty period. Okay, so we're talking about those number of cycles before over that 10-year period. And there's lots of disclaimers here, but this will give you an idea because it depends on lots of different things. But let's just say that if it's 30 cents a kilowatt hour at this current price. So after the current rebate of $4,174, if you're eligible, the price drops to below $10,000 for that unit, which is about $769 per kilowatt hour. And this is the sort of battery pricing that we'd like to start seeing in the industry. That and below that, obviously, because what that does is starts equating to 21 cents a kilowatt hour for the storage. So if you're charging your battery free from the sun, from your solar panels, and supplying energy to your home from that battery, then the cost to you to pay off that battery is 21 cents per kilowatt hour. Okay, which is usually less than what people are buying energy from the grid from. I think the average energy cost in Victoria is around 25 cents, so somewhere between those two values. I just wanted to pop this one in as well. This is from Solar Choice, but it just shows battery pricing variability. The slideshow will be provided so you guys can look at your leisure if you're interested in this sort of stuff, but it's the current snapshot, and we're talking about that 13 kilowatt hour battery, which is in that 11 to 15 kilowatt hour range for a battery and inverter charger, is $1,090. That's the average cost. But then you can see the high range of that's $2,290, and the low range is $650 per kilowatt hour. So obviously the prices are changing depending on the quality of that system. And most likely the brand's being offered. But I didn't really want to talk much about this slide. I just wanted to have it there so you could refer to it at a later date if you wanted to. Okay, we'll get into the rebates and incentives because I'm mindful that we don't have much more time left and I want to leave some time for questions. But so look, all solar systems, and I'm talking about just solar inverter systems, we're not talking about batteries here. But if you were to get a battery, you'd still get STCs. But really the STCs are a measure of how much energy from your solar panels and greenhouse gas emissions you offset over the life. So STC discount is something you can ask for. Solar retailers will always offer an upfront discount on your, okay? So you're never out of pocket. They will get you to sign an STC form after your system's installed and they will claim it, okay? There are different calculations depending on where your system's installed on the face of Australia, let's say. But for Victoria, a 5 kilowatt system is approximately $2,050 STC discount, okay? But that'll be a point of sale discount to you. There's a market value for STCs, which fluctuates a little bit, but it's been hovering around 35 for a while now. Okay, and then I guess the big one is the Victorian Home Solar Homes Program rebates. Now, I just want to note that these rebate amounts are supposed to change and reduce from July 1st, 2021, okay? So the end of next month. Nowhere has it been made public that I can find what they're changing to or if they're changing. So I just need to point that out, that there's potential for them to reduce at the end of June, well, it's the 1st of July. Currently, however, we've got an $1,850 rebate for your solar PV rebate, and we've got an $1,850 interest-free loan matched to the rebate amount. So you can apply for the loan if you wish, and you can pay that back monthly or in installments, larger installments, however you like, but you've got 4 years. It works out to be about, I think it's $38 per month based on $1,850, and it's interest free. Okay, so if you want to install a solar system with that loan, starts getting the savings from your solar panels, the savings you make on your bills pretty much pay off your loan amount over 4 years. There's also the solar battery rebate, which is $4,174. That's now been opened up to all postcodes in Victoria, from what I understand. So anyone, assuming you're eligible, can apply for that. And there's also a solar hot water or heat pump rebate, and I thought it'd be worth putting that in because we spoke about, you know, that heat pumps in particular earlier, and it's $1,000 currently. There are also VEECs associated with upgrading hot water systems, so there's probably something extra on top of that, but as it's not related to this solar specific discussion, we won't go into that. So I think here is that you can only go for one of these rebates. You can't double dip or triple dip. Okay, if you want, you know, to get a solar PV system installed, then you go for that one. You're not eligible for the battery rebate. So just be mindful that you know, you'd be better off going for a battery rebate than you are going for the solar PV rebate. So yeah, you can't double or triple dip. Feed-in tariffs. Another hot topic at the moment, feed-in tariffs. Look, these are the updated feed-in tariff values because it has been made public by the Essential Services Commission now. So from July 1st, feed-in tariffs will be dropping. And that drop will be, there are two different types of feed-in tariffs, single rate and time varying feed-in tariffs. Most likely, I'd say you're probably going to see the single rate just because it's easier, 6.7 cents per kilowatt hour. So I think at the moment, it depends on your retailer because the retailers don't have to, that's the minimum, okay? So the retailer can still offer you more than that if they want to. And some retailers do that because they want to get more customers. So that's one way that they can do that is by increasing the feed-in tariff amount that they offer. So I think at the moment, you know, the most feed-in tariffs are around the 12-cent mark, unless you're on the premium feed-in tariff, which is still up over the 60-cent mark. So that's due to expire in 2024. So you know, those people that got the premium feed-in tariff have been on a good wicket for a long time, and you know, probably haven't paid a power bill since they had their system installed, and probably paid off their gas bill at the same time as well. I know my parents do that. So now there's also time varying. So depending if it's peak, shoulder, or off peak, that'll change. But all you need to know is that the feed-in tariff is decreasing from July 1st. We'll just quickly speak to rebate eligibility, and you know, the solar PV rebate, the battery rebate, or the heat pump solar hot water rebate all have slightly different criteria. Okay, I haven't listed it all here. We've got a link at the end of the presentation so you can look at it yourself, depending on which one may be of most interest to you. But I guess the key is that you have to be the owner occupier of the property. These are standard across the rebates. That the owners have a combined household taxable income of less than $180,000 per year. They obviously haven't already received a rebate, as I spoke to before. It's an existing property valued at under $3 million, and you know, the property address that is now has not previously taken part in the Solar Homes program. Okay, so the person applying can't already have applied for the rebate, and the home where it's to be located can't have had a system installed or an incentive under the rebate scheme. But I guess the key thing here, and I've highlighted that or made that bold, is that you can't have an existing solar system installed. Okay, so if you're starting fresh, you're okay, you're eligible, no problem there, as long as you comply with all of the other requirements, main requirements listed above. There are some other stuff, but I don't think it's that relevant. So the only exception to the rule is for early adopters, and early adopters are people who have had a system and they installed it before the 1st of November 2009. They're the only ones eligible to replace or expand their existing system. Okay, but a lot of those people will be on the premium feed-in tariff, so are probably not looking to upgrade their system anytime soon, until 2024, that is, anyway. So the solar battery rebate is slightly different, and the first point there, I think, is the main one, really. It's the property already has to have PV panels on it with a capacity equal to or greater than 5 kilowatts. So if you've already got a solar system and you're thinking about putting a battery on it, it has to be 5 kilowatts in capacity before you can apply for the battery rebate. So whether that means that you have to upgrade your existing system to be 5 kilowatts first or not, that's up to you. But that's, I think, the main differential there is, whereas the solar homes rebate, you can't have system installed, but this one, it requires that you have a 5 kilowatt system installed as the minimum. Okay, so if you're thinking about maybe solar battery is a better way to go forward, then you're going to have to install 5 kilowatt system without applying for a solar homes rebate, and then apply for a battery rebate to get the best bang for buck as a separate installation and a separate application. Okay, and briefly now, I just want to run through we're approaching the end of the Prezi. So these are the main steps. Okay, so I think I just wanted to put them down on the slide for you so you can refer back to them if you wanted to, but really this is the overview of what we've been speaking about. If you're ready to go and you want to get a solar system installed, these are the steps you need to follow from here on out. So understand your needs, request a written quote, all 3 from your solar supplier. Book a site inspection, and this is really important because some companies will just quote, over the phone. They'll look at satellite images of your roof, but they won't actually come and visit your home and have a look. They won't look at your switchboard. They won't look at wiring runs. They won't look at, where the panels are to be installed. I think it's really important to book a site inspection. Make sure they come out and have a look at it, and then provide a fixed supply and install pricing based on that site inspection. All solar retailers that are worth anything will do a site inspection before signing a customer up, because they don't want to have to tell that customer it's going to cost more on the day of the install. Okay, so this is a key requirement from my perspective, that is. So after that, you apply for the solar VIC rebate. The solar provider, and they've changed the way this works recently. I was surprised to find out. It used to be that you apply for it and then you get paid the rebate, but now the solar provider initiates this for you. So once you sort of agree on the quote, they'll upload that quote to the Solar VIC portal. Then you provide an eligibility number and a QR code, which is a requirement. The solar provider will then submit a pre-approval application to your distributor. And this is really important, okay? And I recommend that this gets done before you accept and sign any contract to go ahead with the works, and before you go through the process of applying for the rebate, to be honest. So you're at this point, you've been provided an eligibility number, which is fine. You haven't done anything else, but you want to make sure that your distributor, so in Windham area, that's PowerCore, is happy with the system size you're proposing, and that they allow you to export to the grid. So this is a bit of a point of contention at the moment, because sometimes systems are being export limited depending on how much solar has already been installed in the area, and sometimes zero export has been mandated in some instances as well. So it's well worth figuring all that out, and then if you're still happy to go ahead at that point, to do so. And have that conversation with your solar retailer. I mean, if it changes the way you approach installing solar, because you can't export as much to the grid or what have you, then you want to know about that before you go ahead with it. So then you upload your proof of identity, your proof of ownership, and your proof of income to the SolarVic portal. You accept and sign the contract for works with the solar provider. And then pretty much they'll come out and install it. It gets inspected by a third-party inspector to make sure it's compliant and that it's safe electrically. They'll issue a certificate of electrical safety once the system's been inspected. And then that gets sent on to your retailer with some other paperwork to get your meter, your solar, or the meter changed to for a feed-in tariff. So your solar provider does all this on your behalf. I'm just pointing out that this is the process that you have to follow. Solar install companies do this on a daily basis, so it's pretty much second nature to them. So you don't have to worry about any of this. The only thing that you really have to worry about is applying for the rebate if you're going for it, uploading your identity forms, the proof of income, etc. And then when it's all over, you pay the outstanding amount to your retailer. So less the rebate and any loan amount if you're taking up a loan for the solar PV rebate, that is. And then your meter reprogramming gets done. That's usually done remotely if you've got a smart meter, which most people in Victoria do. And then you sign a feed-in tariff contract with your energy retailer, and away you go. And that's pretty much the process from go to woe when installing a solar system. So hopefully that's been helpful. So I've listed some resources here in terms of Clean Energy Council, solar, batteries, the list of approved solar retailers, also some information, more information, and more detailed information on each of those solar rebates that are on offer at the moment in Victoria. And thank you. We've finally reached the end of the presentation. So I just wanted to say thanks for attending this evening. Thanks for everyone that hung on the line there. And feel free to sign up for a one-on-one session if that's something you're ready for now. And if not, just send us an email at sustainability@Windham, and we can register your interest for a later date. Any questions?
Thank you very much for that presentation there, Warwick. I might get Carolina to put the link back in the chat for those one-on-one sessions and the sustainability email, and I'll give you a couple quick fire questions, and then I'll scroll back up and bring you some more curly ones in a second. First one, I guess, can the electricity provider decline you having a solar system connected to the grid?
They can't, from my understanding, they can't decline you from having a system connected, but they can mandate how much energy you can export to the grid. So if there's an export limitation, for example, if you install a 5 kilowatt solar system and they say, look, you can install your system, but you can only export 3 kilowatts maximum, then you need to put an export limiting device into the mix. So that's an additional component. But depending on the system, some can do that via software. Some of them will say, hey, look, sorry, at this point in time, you can't export any energy to the grid. It doesn't mean you can't install solar, and it doesn't mean you can't install a battery, and it doesn't mean you can't charge that battery from the solar that you install. It just means that any excess left over can't be fed back to the grid.
And that's actually a good segue into one of the earlier questions we had from Dominic. He said, we've been told that in the saltwater area in Point Cook, they don't have the infrastructure to export to the grid. Do you think this infrastructure will become available, or is that a question for the power company?
Good question. If I looked into my crystal ball, I would say that, you know, it's a massive issue, and it's something that I know they're definitely working on in the background. Look, there was a media release only a couple of days ago from Powercore saying that they want to invest in, I think it's 20 of these really large scale batteries, you know, all throughout their network. And to unlock more solar export capability. I think, the distributors have been caught on the hop, no doubt. I don't think anyone foresaw how quickly the uptake of solar would come online, and I think everyone sort of understands that, whether it's aging infrastructure or undersizing infrastructure, the infrastructure has always been designed for one-way flow of energy, from power stations to homes, and that's it. They never really considered what's going to happen when each house, or every fifth house as it is now in the street, has exported energy back to the grid as well. So look, I think, and I know that Powercore are thinking about it, and I know that they're talking about it internally, and I know they acknowledge that it's a problem. The last discussion I had with them, they mentioned having a solar hotspot program, I believe, which you can get information on that from the Powercore website. They're doing analysis and identifying parts of the grid that obviously are having this issue currently in terms of export limitations or zero export. So I would think that those parts of the grid will be the first that they'll be looking to upgrade with, either grid scale batteries or upgrades, as it may be. Yeah, I hope that answers your question.
Next one, are batteries transportable? Obviously you're investing a lot of money. Can you take them to your next house if you have to move?
Yeah. Well, the quick answer is yeah, you can. Look, there's probably some disclaimer that if you apply for a battery rebate or something like that, then it probably has to remain at the property. But and I don't know. But yeah, look, they're very modular. They're mobile. I don't see why you couldn't take them and install them elsewhere. It depends on the type of battery we're talking about. Depends on the size of them, have you. But I think most of the all-in-one lithium-ion AC type batteries, they're designed to be plug and play. So you can take them anywhere you want with you, and you don't even need a solar system, to be honest. You can install one of those batteries on the switchboard of your house and not charge it from solar. You can, and a lot of people were looking at doing this. They call it arbitrage, where they charge the battery during off-peak times at low cost and then export to the grid during peak times to make a profit that way. So look, there are different options, but yeah, I think that most of the battery systems are fairly modular, and I would think that you could take them with if you wanted to.
What maintenance is required on the system components?
Good question. Look, realistically, I think cleaning of solar panels is required. I can only speak to sort of what I know, and cleaning and maintenance of solar is key to get the most output from your system. So I would say to people that if you're up cleaning your gutters once a year, then it's probably a good time to give your solar panels a bit of a tub as well. String inverters, there's not much that you really need to do there. You just need to make sure that the vents on them are clean. They're the sort of places spiders love to build a nest and hang out. So just making sure that dust and spider webs are cleaned and the inverter can actually breathe, I think is important. Look, I don't know what sort of servicing and maintenance is required on batteries, to be honest, and I think probably battery manufacturers don't want you poking around inside their boxes. So it's probably better to get an electrician to be doing that, just to make sure that it's operating. But look, most of these battery systems are going to have a monitoring system associated with them. You're going to know, and particularly with the better brands, they have back to base type monitoring. So if your battery goes down, they know about it usually before you do. There are a couple of battery brands that we've been dealing with at Windham, and I must admit that both of them are pretty good in terms of notifying if there's an alarm or something like that that's happened with the battery, or the battery goes offline for whatever reason. So typically with the better batteries, if you've got that sort of back to base type monitoring, then I don't think you have to worry about it too much. But yeah, hopefully that answers that question.
Can you get your solar system initially set up so it's configured to be ready for blackout protection and then get a battery attached later? Or does that all have to happen at the same time?
I'm reading between the lines on that one. I think if we're talking about wiring the board for supplying essential loads, that could probably be done at any time, really. That doesn't matter. But I think it's probably better to get the person that's installing the battery to do that on your behalf, because then all that work is as one. You may not use the same solar company to install your solar panels and original inverter to then add a battery at a later date. So if for some reason it doesn't work like you think, then there could be some issues there by using multiple contractors. I would think it'd be best just to configure it all at once you've got your battery in place. Yeah.
We do have a quick question about yourself, Warwick. What's your background? Are you an electrician or electrical engineer with solar specialty?
No, I'm not an electrician or electrical engineer. I'm actually studied mechanical engineering at university, but it seems that I always have been working on electrical type systems since then. So I did a master's degree in photonics. Off-grid solar and solar installs during my mechanical engineering degree was probably the thing I enjoyed most in terms of renewable energy in that field. So that was one of the main drivers for me to get into this field now. So yeah, I have an engineering background, but not electrical as such. Yeah.
And I'm going to combine two last questions here, and then if anyone does have any more questions, I'll get Carolina to just drop our email in again, and then you can send them across there and we'll get back to you. But Anonymous has asked, I've had my solar system installed 5 years ago with the rebate. So am I eligible for a battery rebate still? And also there's another question just here asking, how long does the rebate application take?
That's a very good question. To the first point, I'm not sure. I'd want to say that you may be eligible, but I'm not exactly sure. So you had 5 years ago. If you're a home program, then definitely not. Because
Sorry, Warwick, we've lost you quite a bit there.
Okay, sorry. Can you hear me now?
Yeah, for some reason that's better.
Okay. Look, I don't know. You'd have to ask the question of a solar retailer, I would think. But look, I doubt it. I doubt if you've already received a rebate under the Solar Homes program. I think that'd be considered double dipping to go for the battery rebate. But you'd have to figure out whether the incentive you received when you installed your system is eligible or not, or classifies as that Solar Homes rebate now. I don't know, to be honest. That's the truth of it. And what was the second part to that question? Sorry, Dan?
It was just if you had any idea how long the rebate application took to be processed.
Yeah, look, I don't think it takes that long, to be honest. And I think early days it was a bit of a nightmare with the system. It was difficult to secure rebates. The resident had to do a lot of the heavy lifting. They had to be online at a certain date and time to actually start applying before the rebates were all gone. But I think Solar Victoria have done a really good job terms of streamlining it now. And a lot of the work is actually done by the solar retailer. So I got a feeling that, you know, initially a bit of the hold up, and it was only 2 to 3 weeks from what I understand, was with the rebate back to the resident or to the customer. But now that rebate, I think, is paid directly to the solar company. So you're never out of pocket that amount. So it's actually up to them to get that rebate. So the delays, if there are delays, that is, won't impact you at all. It's pretty streamlined. Yep.
So we might just leave it there, Warwick, because we have gone a fair way over time. But thank you again for the presentation, and thank you for everyone that's attended tonight and stayed on the line and submitted a question. We hope you did enjoy the Energy Smart Homes program. This information all the sessions that have been recorded and will appear on our website at a later date. We'll send around some emails to everyone that has taken part as well, so you can follow up and get those resources. But yeah, we hope that you're well and truly on your energy saving journey and that you've enjoyed the program. Have a good night, everybody.
Thanks for joining us, guys.